Hello, I'm Mike Camini. I'm currently a student in the online game design bachelor's program at Full Sail University. This is my video for Kastro Hamid's Fundamentals of Physics class.
One of my favorite video game genres growing up was the flight simulator, more specifically, the spaceflight simulator. One thing that always bugged me though with the X-Wing and Wing Commander series was the sloppy physics used for thrust and momentum when all the action took place in the near vacuum of space. The problem was, the craft always decelerated to match the thrust of the engines, even after the application of afterburners, and followed the nose for its forward momentum. I always felt this detracted from the gameplay, as there was a host of maneuvers and strategies that could have been used that would not only make the game more realistic, but even more fun as well. What do I mean? We'll briefly examine how momentum works for an earthbound craft, and compare the conditions with the far reaches of space. In the interest of brevity, we'll mainly deal with air resistance. An earthbound craft uses thrust to gain speed and then to maintain its cruising speed. A 16,000 kilogram craft requires 3.6 megajoules to achieve a cruising speed of 500 miles per hour, thrust equaling mass times acceleration. Once it reaches this speed, it has 3.5 million newtons reacting against it, making its acceleration equal 0, but the momentum constant. Afterburners can accelerate this craft to speeds reaching Mach 2, but once the afterburners are cut, friction causes the craft to decelerate to its original cruising speed. If you cut the thrust completely, the friction from the air causes the craft to decelerate and eventually crash. All this works according to Newton's third law. For every action, there's an equal and opposite reaction. Now let's transpose this to outer space. The same craft requires the same amount of thrust to achieve acceleration. But once the desired speed is reached, it does not have friction working against it. Thrust can be cut completely, and it will travel along at the same speed. Afterburners could conceivably be used to cause the craft to go even faster than regular engines, but once the speed is achieved, cutting the afterburners does not cause the craft to slow down. Again, it has no friction working against it, so maintains constant speed. This illustrates Newton's first law of motion. An object in motion will remain at a constant speed along a straight line of path. The only way to slow the craft down at all is to apply thrust in the opposite direction. To stop it, you must apply an equal amount of thrust to that originally used to accelerate the craft. This allows for all sorts of strategies that are not available to earthbound fighter pilots. The one I always wanted was the ability to cut thrust completely, turn around while maintaining the same momentum, aside from the small amount of momentum lost due to the side thrusters, and pick off those annoying enemy pilots on my tail.
If game designers took a more realistic approach to the spaceflight simulator, it might revitalize a once popular and proud genre of video game. That's all for this month. Again, I'm Mike, and thank you for your time.